Okay, so that geodesy part is, as I've told you, most important part. The reason is very simple. Any kind of tool which is in the space, okay, any kind of tool. When I say tool, do not think is as in terms of any equipment which you have in your hand. They are also tool. The GPS is also a tool where you have satellites in the space orbiting around the earth, and they are transmitting the signals. You have a device in your hand with which you are just accessing those signals, although those signals you cannot see it from your naked eyes because they are having these properties and they are in the radio band. Okay, so what is really happening is you have to get those signals, and inside the hardware of your receiver there is something which is uh, uh, the so-called advanced electronics computer science domain. They are all involved to get you this position. Now many a times we as engineer, uh, we think that okay, we have got the solution, that's our job is done. But my dear students, our job is not only to provide the solution, we have to also provide the solution that could be relatable, that could be, somebody could understand that. You could also explain its physical significance, and as well as it should have some mathematical background as well. Randomly just giving you solution in terms of points doesn't serve the purpose. It just, you just tell me that my location is 1000 comma 1000 comma 1000. It doesn't serve the purpose. Although from engineering point of view you have just provided the solution, you get this 1000 comma 1000 comma 1000 as location, but it doesn't serve the purpose. Okay, so it is the high time that you understand this aspect as well, that whenever any techniques, any advanced techniques providing you the solution, that solution has to be relatable. We could also understand it in a certain sense that it should be physically defined, it should be geometric in nature, as well as there is some mathematical background supporting the your so-called solution. Now that is, this is one thing which many a times while going through the literature or going through the content throughout the semester, the student miss this point, that our job is to only provide solution. Now whenever something or some just like in your previous semester, your viva was horrible because you have understood the concept. I have asked nothing difficult, I have asked very simple concept, but your answer is very, और 10th लेवल स्टूडेंट है भाई, ए से बी पूछा है तो आई विल ओनली आंसर ए टू बी. Now the moment how y comes, you just baffles around. So that is not acceptable. See, the more you gain the knowledge, the more you will have so-called you know uh, exposure to cover the length and width of the subject. The limit, the moment you apply certain limit to your knowledge, what will happen? You will only work to a certain extent. That's it. So this semester you should be, uh, uh, I mean, improve yourself in terms of your thought process. Your thinking should be much more, expensive in nature. You should not limit yourself. So that's my suggestion in this before starting this semester. Now, in majority of the techniques which we are covering for positioning, okay, let me tell you, there are a lot of techniques available for positioning purpose, but we are reading GPS because it is very popular as well as very commercial in nature, so that users are using it. You would be users after some time. Then you should be aware about its working as well as its principle. But at the same time, you should also understand that in under which category it belongs, isn't it? So GPS, if it is a positioning algorithm, let's say, so where it belongs, so it belongs to the category of space geodesy. There is a term called space geodesy. Okay, that space geodesy part is you know is a broader domain of uh, geodesy. When we study geodesy, we study two types of or three types of mainly geodesy part. One is called as physical geodesy, one is called as geometrical geodesy, one is called as space geodesy, and extraterrestrial geodesy are also studies nowadays, but we just limit ourselves to physical, geometrical, and satellite geodesy. So in the satellite geodesy domain, you have VLBI, you have SLR, you have LLR, you have GPS, you have INSAR. So these are a part of your the so-called you know domains of space geodesy, where you are understanding the different concepts. So GPS is just part of your space geodesy. In this space geodesy part, the objective is very simple. Definition of geodesy, I've told you in the last semester, is that study of Earth in terms of measurement of its size and shape. So we are measuring the size and shape of Earth with different techniques. So when the size and shape of Earth, your mother nature Earth, is studied from space with the help of satellites or any techniques that is located in the space, that technology or that particular domain is called as space geodesy. Okay, you get my point. This space geodesy is something which you should understand as the technology which is helping us in studying the or measurement of size and shape of Earth. That is first part. So whenever somebody asks, so in fact you will have many you know with, many techniques are evolved in this category of space geodesy, and many times you will also see a book named as Space Geodesy and GNSS. That's the book name popular, or GNSS Satellite Geodesy. That's the kind of book you will see. So that's why this is a broader name, and people are simply using it. So from that aspect, I'm telling you that this domain is important. Second part is that in the case of geodesy, or in the case of, let's say, GPS, what is really happening? You are getting the positions, isn't it? But that positions is 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 something which needs to be referred with respect to certain reference. Just like in previous semester, you have studied about height differences, isn't it? You have seen different level net problem. Okay, and in that level net problems, you have seen the heights you have adjusted. These heights were the mean sea level heights, and this so-called heights which GPS is measuring is called as ellipsoidal height, that we have got through and discussed at certain point in the last semester, that the heights that we are getting from GPS is ellipsoidal height, and the heights which we are getting from the local mean sea level survey or mean sea level information that we are getting, that is known as orthometric height. So two heights are different, and they are different with the with that one term which we call it as geoidal undulation, or a capital N value, for which we have seen the whole globe map for N value, because various satellite missions are in the space for studying the gravity of the. This geodesy domain is very emerging. I mean, uh, uh, very emerging in the sense that very few people have started working in it in India. Only handful of people are working in it, and there are a lot of fundings and a lot of opportunities are available. And I'm very proud to announce to you that MNIT has been selected for establishing a regional center of geodesy at our institute, and we have got certain funding from Department of Science and Technology. So they will be helping us in establishing a laboratory, will be providing certain instruments, certain sophisticated instruments that will be used by you people for studying various type of work related to geodesy. It's very emerging field, and uh, in future many government organizations are, every state government, in fact, in their revenue department, they will be having the geodesy officers in future. We are recommending to various state government to have these kind of specialist officers that will be helpful for the because what is revenue? If you see what is the revenue department doing, they are the patwari, the lekpal, they are just doing the mapping. But that mapping from their point of view is different in nature, because they are doing different type of measurement scales. Their units are different. They are working with a different kind of methodology, but ultimate objective is same. They just want the detailed map. In fact, you must be knowing that in recent years there is a scheme from Uttar Pradesh government, which is called as Gharoni, where the villages home or houses are mapped by UAV, and that Gharoni or the scheme is providing the labeled map of a particular house in a certain village, and that will be named to households, majorly women's, and that will be used for providing the loans, because till date nobody is providing the loans on that kind of house, where which is located inside a village, because they do not have any kind of registry over it. They do not have any records over it. So that's why the objective is multifold, but our point of interest is that this has been done by UAV based mapping, and I have been involved in certain type of discussion in that part. So that's where we have seen that this revenue department has much more work, and that's why we are recommending to have it. Let's see how many discussion we need to have with them before they are going to eventually start this Lakepal. I mean. Post has to be modified, because if it can't be modified, then there is no purpose of doing this revenue kind of work. So you cannot just have a simple graduate, BCom graduate to work for this particular work. It has to be some engineer that should be working with the specialist knowledge of the so-called geospatial techniques, measurement techniques, mapping techniques. Okay. Having said that, so you will be very proud to host this regional center of geodesy at MNIT, and you will be hopefully, with situation being normal, you will come to campus and you will have access to those advanced instrumentation which we'll be having soon, and that will be there for next 5 years. So let's see. Anyways, in this part of geodesy, as I've told you, that we have a geodesy, physical geodesy, space geodesy, geometrical geodesy. So geometrical geodesy we have done in the last semester, where you will be using total stations, GPS for mapping and so on purposes, and then you will be using it for various kind of applications. Similarly, in physical geodesy, you will be more interested in looking at Earth from the space and trying to observe the gravity field of the Earth, because you must have seen Interstellar, isn't it? That in that Interstellar, the fourth
dimensions that the lead actor is talking about is the gravity. So that is the dimension which Einstein has also worked on, and many a times I don't know whether you are more connected with the outer world in terms of science and technology. That the various leading institutions, be it Stanford, be it Harvard, be it Caltech, they are all working in the quantum gravity nowadays. That quantum gravity will take to another level of discussion where you could see the gravity behavior as one of the possible dimension apart from your position time. So many scientists are working in this domain. In fact, one of our Indian student is also working in this quantum gravity at Caltech. So let's see in future what we have. So there is two possible mechanism. One is Einstein theory of specific relativity, general relativity, and that's Newton laws of classical mechanics. So they are differ in defining the uh, gravity. So Newtons have defined gravity simply by mass, the attraction between two masses, and then Einstein has come up and defined gravity in a different sense. Anyways, well, you can go ahead and watch many acute YouTube lectures to have more knowledge on it. But this is the future. So quantum gravity is the leading science and research field in coming days, which we will also be working on. Okay. Anyways, and second work uh, which I was telling you is that in this particular course, let me just come back to again to our discussion part. So in this course, we will be first covering majority of the content of geodesy. In that geodesy, we will be discussing first about the coordinate system that are relevant for GPS. Okay. Now, how coordinate system is relevant for GPS? Let me just explain it to you. You can see or visualize at this particular time that your satellites are in this space, isn't it? Your satellites are in this space, and they are orbiting around the Earth. Okay. Now, can you imagine that satellites which are orbiting around the Earth is at what distance for GPS case? Are you aware of it? Can anybody explain me? Anyone? Sumit, am I audible?
Yes, sir, you're audible, sir.
हम्म, मुझे लगा शायद आवाज नहीं आ रही. What question I've asked?
Distance of satellite from the Earth.
हाँ भाई, जीपीएस के लिए बताइए क्या होगी, कौन बताएगा?
सर जियोस्टेशनरी ऑर्बिट में होगा वो तो लगभग सर 400 to 700 किलोमीटर्स फ्रॉम द
अरे कहाँ 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 भैया, कहाँ? अधूरी जानकारी खतरनाक होती है. 400 to 700 are called as low Earth orbits, which is also known as LEO. That's what I'm telling you. No? People are not reading much. If you do not read much, then you will have less information. 400 to 700 is bulky. In fact, even nowadays it up to 900 kilometer also from Earth's surface. You will be calling those orbits are called as LEO, low Earth orbits. Your all kind of imageries, the imagery which you are using for your topographical mapping, the image which you can visualize, they all are coming from LEO. All kind of sensors, scanners, they're all in the LEO. The GPS or the so-called positioning satellites is at the 20,000 kilometer. I'm just again repeating, 20,000 kilometers from the surface of Earth. You just think 20,000 kilometers. Then the geostationary orbits, which you just, Sumit, just mentioned, is at 35,000 kilometers. Why they are called as geostationary? Because it looked as a geostationary. Their behavior is as geostationary. From Earth, they looked as a stationary point because they are well rotating with respect to Earth. So that geostationary satellite for telecasting your broadcasting or any kind of communications, they are used because their job is to broadcast a particular signal in a particular area, so that the same information could be provided to end user. Okay, आप स्टार भारत को या स्टार प्लस को कंट्री के दूसरे चैनल में सेम टाइम पे रियल टेलीकास्ट नहीं देख सकते. ओके, दे आर डेडिकेटेड टुवर्ड्स अ पर्टिकुलर रीजन. ओके, दूसरे कंट्रीज के चैनल्स अलग होते हैं. आप यहाँ पर देखते हैं स्टार स्पोर्ट्स, ऑस्ट्रेलिया में होता है स्काई स्पोर्ट्स. गेट माय पॉइंट? या प्रोबली यूके में भी स्काई स्पोर्ट्स चलता है. तो you have a different group of channels, but they are transmitted via different set of satellites. So for Australia, they would be having some different geostationary satellites. For us, we are having different communication satellites. Okay, what is India's first geostationary satellite? Can you name it? It's a GK question.
आर्यभट्टा.
आर्यभट्टा नहीं है बेटा, एप्पल.
SS.
This is the first geostationary satellite. Anyways, थोड़ा पढ़ाई करिए आप लोग. ये आप लोग कच्चे घड़े हैं, थोड़ा इस पे अच्छे से मेहनत करिए. Okay. Anyways, so I was talking about, yes, the satellite which are at 20,000 kilometer away from you. Can you imagine you are using a signal that is coming from 20,000 kilometer, and for the time being, let me just also tell you that some of the satellites in some of the countries of similar to GPS nature, although their name is not GPS, it is because GPS is also a part of GNSS. GNSS is called as Global Navigation Satellite System. So GPS is just one part of GNSS category, broad category. Russians have their own, Chinese have their own, European they have their own, Indians they have their own, but some countries do not have a navigation system which is of global in nature, just like we. Our Indian GPS or so-called Mavic, it is not so-called global in nature. It is an Indian regional navigation satellite system. It is called as IRNSS. You get my point? So IRNSS is called as Indian regional. It is Indian region, not global. Similarly, you have QZSS, which is Japanese. It is also not global in nature. Okay. So, but it is available in Indian continent, although it is available, but it is not global in nature. Okay. So that part of information you must know, that GNSS is a broad category, which is called as so-called Global Navigation Satellite System, and GPS, Global Positioning System, is part of it. Okay. So we are having GPS satellites at different altitudes, but in general, when we are reading about GPS, GPS is at 20,183 kilometer. That's a specific value. 20,183. 20,183 kilometers away from Earth's surface, and they are transmitting the signals. So can you believe that those signals which are transmitted from such a large altitude, that will be used by your small receiver in your hand, and you will be getting precise position, not precise, the level precision, isn't it? You just think, whenever we say certain units, you do not get into the essence, the physical significance of that value. Just say 3 mm. Can you see 3 mm? No, you cannot see from your naked eyes the 3 mm value. Okay, because it's a very highest possible precision that is available. At present, you can work at 1 mm level with the help of that GPS. So just think of this, this technology, and you can imagine at what type of sophisticated algorithms, hardwares that are involved, that are providing you this millimeter level precision, with help of which you are tracking your. I don't know how many of you have used this Google navigation in 2010 or maybe 2011, but most probably if you have used it, you would have seen in 2010 or 11 or maybe 10, before 10, you would be getting a dot with a blue circle around it. But that is the error or uncertainty circle of your position. But nowadays it is vanished, it is gone. You do not see it more frequently, because the precision of position where you are actually is much more precise. The answer is much more precise. Your as uncertainty level has decreased a lot. So that's the beauty of the technology. And anyways, we would be more interested in understanding that concepts, that little concepts. But again, if we cover lot more basics, we cannot cover the so-called. So what I'm telling you is, we would be I mean, I need your support, all of you, so that we could also quickly cover the basics as well as some of the advanced content, so that your mind should open whether where I should be looking at this use of this technology in certain domain. Otherwise, if we cover whole semester in the basics part only, then there is no point, because otherwise we would not be discussing more about the advanced content. Okay, so the content which I'll give you as part of assignment, as part of regular reading, you should read it, you should reply back, and you should ask, or involve in a discussion among yourself in a separate group, maybe on Google Meet or somewhere. You discuss about the technology, you discuss about the content, because otherwise there is no purpose to read about those advanced technology, until unless you are discussing among yourself about the positives of those technology. Okay, so just think in that domain. So what is really happening? You have satellite which is orbiting around the sun. Okay, let me. I don't know whether uh, in, just a minute. I'll just see whether it is a. Okay, I'm just resharing one YouTube slide. I don't know whether you could be seeing it. Is it visible, Sumit?
Yes, sir. Yes, sir.
Just see. So that's how your initial few satellites. That's how your initial few satellites looks like, and then this is a huge set of satellites that are in the space for different purposes altogether. You could see how they are oriented, how they are projected to a particular orbit. So you see your Earth, and then you see such penny small satellites, but they are solving your purpose. They are moving around without having any disturbances to them, to any other satellites, and they are working. After their lifetime, they becomes the garbage. So that is a space garbage. We can have to, in future, we have to minimize that garbage also. Otherwise, we will be in a very difficult situation. But anyways, at a particular satellite, which when it is moving in a particular orbit, its position has to be known also in millimeter level. Again, so you are relying on satellite, but satellite in fact relying on us. So it is a two-way kind of uh, give and take relationship between us and the satellite. So we are the users, so satellite do not interact with us. Okay, so we are not users, so satellite do not interact with us. In fact, they interact with the control segment. So somebody who's controlling those satellites, they interact with them, and they show with their behavior that they are in the help, they need some help from the control servers. And when they are getting those kind of help, we are getting a precision information in terms of our position. So if the satellites are left alone, we will get meter level resolution, and if they are properly supported by us in terms of ground control segment, then they will get uh, their orbital location should be much more precise. So when I say orbital location, their path in the orbit is priorly known and is being feeded to them, so that they have to move in that path only. Okay, so a satellite which is orbiting around the Earth, they have their pre-justified or pre-predicted paths to them, which on that path they are moving in the space. But at the same time, they are transmitting the signal to us. Okay, so when they are transmitting the signal to us, we are using that signal. We will be using that signal, and we are getting our position. In that signal, a lot more information is being transmitted from satellite end, because it is one-way communication between satellite and user. We are user, you are users. Okay, so as a user, you are only getting information from the satellite. You are not transmitting anything. You cannot transmit anything to your satellites. You are just receiving it. Okay, so when satellite is transmitting to you every kind of information, it needs to be make sure that you should get everything whatever required to you. Okay, please remember that in the case of GPS, the information which is transmitted to you is having encrypted. That means that information cannot be accessed by unauthorized user. You are authorized user because you have the receiver, but somebody who's not having receiver, they cannot access it. Okay, in your mobile phone also, you can only get the position. You cannot access the raw files, which your mobile company is having some MOU with the agencies, that they will only process and give you the position. They will not give you the raw files. But some apps are nowadays are available, that when you install those apps, you can access to the Rhinex file, which is the raw file, but still you cannot access the signal. So what I'm trying to say is, you will get the solution, or you will get the certain level of observation file, but you will not get the raw signal. You cannot land on your hand at the raw signal. What is the raw signal coming from the satellite? When I say raw signal, that means that is encrypted. Obviously you get answers, which is after decryption you get the answers, but you cannot have access to an encrypted value of the data. Anyways, so that that raw files which is given being sent by the satellites are signals or modulated signals. Just like you have read in your BTech first year, the different types of amplitude modulation, frequency modulation, phase modulation. So that is the modulation techniques, which one of them is using, one of them is used by GPS or technology, and that modulation will be used for transmitting the signal. From that, from satellite end to receiver end, the signal is transmitted through a modulation technique. Modulation is done to you know tell you a lot more information required for positioning. Please remember, when you heard that you are listening to 92.7 big FM, your ears are not capable of listening to 92.7 megahertz. You know that. Why? Because it's a very sharp chirp which is there in 92.7 megahertz. Our eyes are only capable of 25 to 30 25 to 30 kilohertz kind of information. In fact, I'm just I sorry, I think it should be only hertz, not kilohertz. Why? Because we are speaking at a very low frequency variations, so that your ears are capable of. But if you could listen, or you could somebody could say that 92.7 megahertz frequency is this, you cannot even identify. It is the carrier which is identified as 92.7. It is the carrier, it is the frequency on which your song is modulated and it is being transmitted. You get my point? So that similar nature in the GPS also, you have very high frequency carrier over which through modulation your information is modulated and being sent. Okay, that information once received by the said receiver is unmodulated or demodulated, and it is used for so-called uh, for various positioning purposes. Okay, so one point is your orbit needs support from you. So in orbits you have satellite position is also required. When satellite position is known to you, and when I say position of a receiver, that means you have a receiver. Just imagine you have a receiver and you have your position available to you. What are the components or what are the information that you need to know before you get the position? You need to know the satellite position in level. If you are talking about level in your ground position, you need to have the satellite position in level also. Plus, you need to have the range between satellite and you. So in your basic problem of last semester, I've told you one problem called as fixing the ground points. That means fixing a point on the ground. And for that, what you have done? You have chosen multiple fixed point and you have taken the measurement from those multiple fixed point, and you have taken the ranges towards that the point of unknown. And then once you have three fixed length from three fixed point, you can easily fix that point. That concept is called as ground resection. You get my point? That concept is called as ground resection. The GPS is an example of space resection. Why space resection? Because in your in your GPS case, you have satellite in the space. Okay, in your case, you have satellites in the space, and the satellites are moving, but they are transmitting the signal. So you are using that signal to generate the length between or ranges between satellite to user. And then you also need to know the satellite position. So satellite are behaving as a moving control points. So in the ground resection, you have fixed control points, trees, poles, building corners, some gate, potholes that are your fixed control points. But in the space section, you have satellites. None other than satellites are your control points, but they are called as moving control points, and their positions are known in level. Then the length is also known to you, and then only you can fix your point on the space. Okay, so you can search or read more about this so-called ground resection and space resection, and there is much more literature which will be available to you on both ground resection versus space resection. Okay, but you must also understand this part, that what is a space resection, what is ground resection, what is how the ranges are computed, so that are the moment when we say it, we all go and we discuss one by one each and every content for you know so-called different components. Just a minute. Okay, so in the second part, let me just again see what was telling. Yes, so let me just share it also to you. So in the first unit, or first point of discussion, we'll start with elements of geodesy, where we will see about the shape of Earth. Then we'll see about the tides. And then I just have told you the coordinate system, which are very much important to get you the position in certain reference system. So we will see what are the terrestrial reference system, what are the inertial coordinate system, what do you mean by Earth orientation parameters. Okay, so this is your first our first point of discussion that we will be having, and then we will go much more in a much more detailed discussion about the shape and figure of Earth, the potential and geoid terrestrial coordinate system, that we all cover it. Then we'll discuss about the Earth center, Earth fixed coordinate system, then the topocentric system. Then we will discuss about the geoid ellipsoid, although we have covered it, but we'll again revisit it. And then geopotential, the coordinate system. Then we'll see about the reference ellipsoid. What are the different? Although we have covered it again, reference ellipsoid have already been covered. Then we will discuss about the datums and some of the issues with the datums. That is part of our discussion that we will come. And then in the second following segment, we will we will see how we can discuss about the Earth rotation, because it is more important. And most importantly, we discuss about the time system. Okay, so some time systems will be discussed. What are the critical time system that we are, because the satellite, when it transmit the signals, it is stamped. When you receive it, you stamp it. Both two time system are in different with respect to different reference time. So we need to understand that also. Then we will discuss about the conventional systems and frames. What are the frames which we are going to use? How this variation in the Earth rotation is helping us, and there is a problem for that also. Then we'll discuss about the polar motion, Chandler wobble. Then the time system. Obviously, the time system is very easy to understand. It's very not a difficult at all. And then we discuss about the various reference frames, the inertial frames, terrestrial frames, as well as the earth orientation parameter and why the earth orientation parameters are required. So these are the part of your basics of geodesy. Once we are finishing that part, then we'll come back to GPS basics. When we study the GPS basics, we will see about you know uh, about the different history or historical evolution of navigation system. We'll move from history of navigation system to US satellite navigation system, then Navstar GPS component, and then some advantages and limitations. Then we'll come back again to discuss the so-called observables, the different observables of GPS, and we will also see the principles, the basic principle of GPS working, how the signal structure looks like, why GPS signal is so complicated. And when I say that you are going with the positioning, then when we say that you are getting the positions using GPS, how actually you are getting the position, whether it is a code based, whether it is a phase based, what do you mean by point positioning, what do you mean by relative and differential positioning. So there are multifold aspect of this course. At one point, we will go into depth of the how GPS is working, and on the second hand, we'll see how we can use it. Because ultimately, it's very rarely that you would be developing any parallel hardware for GPS. But what is more important is that how well you can use it. There are several techniques. There are several positioning techniques that are available nowadays, and you will be. I mean, if you are available in the campus, that would be much helpful, so that you could access to your so-called data set from live. You can use your receiver, you can get the data set. Then based on understanding, so first we'll cover geodesy aspect, coordinate system, the time system. Then we go back to GPS basics, the GPS principles, and then we will go back to GPS observable. What are our prime observables? Whom do we call it as our observables? So uh, we'll have pseudo ranges, we have carrier phases, the formats of the data set. What do you mean by Rhinex format? What do you mean by Sinex format? What do you mean by Ionex format? And then the services, the international efforts, and then the model. Now, when you all have seen this in your previous course, that you can develop a v is equal to x minus l kind of model, isn't it? Your GPS is having that backbone. The least square adjustment is the backbone of any GPS system in the world. Why? Because you have the data set, you have the observation file, and you just have to fit in the model. So we'll discuss how that model can be prepared for models for port pseudo ranges and carrier phases. We'll see details about those mathematical models from single versus relative, static versus kinematic, real time versus post mission. Then we'll go ahead with the discussion about GNSS ranging models and solutions. We'll see about the some of the advanced techniques here. We'll discuss that also. Then certain data combinations which are useful for providing the solution. Then we'll see about the error sources, because everything cannot be black and white. It has something has to be gray. So we'll see what are the error sources are there in your observation. We will discuss about that also. And then we will discuss about how the satellite coordinate computation has been done, how you can compute the satellite coordinate if you get the raw data. Okay, so that files, with the help of raw files, how you can compute the satellite coordinates. That is very important, you should know it. And then obviously the survey methods, which we will try to see how many of you are much more interested in getting into the details of the various positioning methods. We'll also discuss there are 2-3 components. One is we call it as an atmospheric remote sensing. So one key component we will discuss about how GPS can be useful for atmospheric remote sensing component, because one of your PhD student is working on a GNSS tomography, because that GNSS would be used for tomographical application, where you will make the profiles of water vapor in the troposphere. So that's how you see the whole lot of content. So it is not only a signal, it is a very valuable signal that is coming from space. It is interacting with ionosphere, it is interacting with troposphere, it is coming to you. It is giving you a lot more information that you can use, and you can solve many of the nature's problem that are limiting us to reach any new heights in our science and technology. So we will discuss that part in detail one by one. Anyways, any questions from your side? Any expectation from that particular course, which you should think that I should include it here? Just tell me. Hello.
You're audible, sir.
हम्म। चलिए मैं एक एक करके पूछता हूँ। हाँ भाई, आलोक कुमार, आप बताएं।
How much do you know about GPS before, and what do you think that where and how much you can use? आपकी आवाज नहीं आ रही। हेलो।
यस सर।
बताइए। बोलिए भाई।
सर ठीक ही था। तो सब कुछ तो मतलब एक बार में तो नहीं ग्रैस्प कर
हाँ
पाया तो
हाँ, अभी
टाइम।
नहीं, अभी समय लगेगा।
हाँ
नहीं, I was asking a different question. I was asking what different question is the GPS understanding of GPS which you had before. Do you think that you would add much more value to your information which you had before while we had little discussion today?
यस सर।
आप सभी लोग थोड़ा सेफ रहिएगा, क्योंकि केसेस काफी बढ़ रहे हैं, है ना। आपकी क्लासेस तो ऑनलाइन